Good afternoon, everyone. My name is Steve Bannerman, and this video is in support of the Python serverless server discussion that was written for the CloudDoc.io article on Rosetta Salt. And so the goal for this video is to walk you through the process of building up the platform on an Amazon Linux machine, EC2 instance, and then to deploy an instance of this Chalice application that's described on the CloudDoc article. Okay, so if you take a look on the upper left-hand portion of the screen, I've got a set of instructions for myself and for you to look at, and I'll follow through those, try and explain it as I go, and hopefully you'll end up finding all of this useful. Okay, so where do we get started? We're going to first of all log into this EC2 instance. I'm going to assume that you've done that before. And the first thing I'm going to do is go through like step one. It says in the top left hand corner I'm going to try and get the development platform set up. And the reason I'm doing this on an AWS Linux instance rather than my own is really, I guess, just the hope that it might be a little bit more repeatable for the general public. So I'll go ahead and run the sudo yum update. Then I'll go ahead and install git. After I do that, I'm going to show you that Python is installed on this machine already, but Python 3 is not installed. And depending on your level of expertise with Lambda functions and so forth, you'll know that Python 2.7 and various 3-point versions of Python are supported there. But since Python 2.7 is deprecated, I think it's better if we go ahead and incur the effort of getting Python 3 onto this machine. Okay, so I want to show you a few things before we get started here. This doesn't really add a whole lot of value in terms of getting the Chalice app deployed, but it may come in useful for you and others at some point. So let's take a look at where Python is currently. It's in user bin. Let's go to user bin, and I want to show you a few things about what's in user bin right now. So you see that there's Python symbolic link and a pip symbolic link, both of them to etc alternatives, pip and Python respectively. Okay, and let's go ahead and we'll go over to etc alternatives and we'll do the same thing there. You can see that the pip symbolic link in there points back to the user bin pip 2.7, and Python there also points back to user bin Python 2.7. Alright, so let's go ahead and install Python 3 onto the platform. So first off, we want to list the Python 3 options. We do that by typing sudo yum list python 3 star. You can see that Python 3.6 is the latest version. So we'll go ahead and install Python 3.6. Okay, so once we've got that installed, let's take a look again at what we've got in etc alternatives and in user bin. So a few things to highlight here. We now have Python 3. It's also pointing to an etc alternatives symbolic link. Pip has not changed. Python has not changed. We go over to Etsy alternatives. Take a look again. We got pip, Python 3, but no Python 2. So let's make a few changes here. I'll just interject a caveat here. I'm not sure whether this is actually the best way to do this. I really just ran into these problems earlier in the day and sort of found a way around them. So I'll just give you that caveat. It may not be the best way. So I'm not terribly familiar with Etsy alternatives, but I think what we'd like to have here and in user bin would be a clear delineation of Python 2, Python 3, and sort of the current Python and pip symbolic links. So here we've got a Python 3 that looks fine. Python pointing to Python 2. So why don't we go ahead and just change that. So sudo move Python to Python 2. And let's go ahead and create a symbolic link. User bin Python 3.6. We'll call that Python. Okay, so if we look at it again, we've now got those. Notice that we don't have a pip 3 yet, but that's going to be coming in a few minutes. Okay, so we'll go back to user bin. Inside of here we've got Python, which is a symbolic link to Etsy alternatives Python, which is fine. But let's go ahead and add a Python 2 as well. So sudo ln -s Etsy alternatives Python 2 Python 2. Okay, so I know this is a little bit laborious, but it's actually shorter than it would take if I were to show you the whole route that I took, and hopefully it'll be useful enough for you. Okay, so let's go back to our home directory and check a few things. So now we have Python pointing to Python 3.6, that's good. Python 2 pointing to 2.7, that's also good. Python 3 pointing to 3.6, also good. If we look at pip, we can see that it's version 9.03 for Python 2.7. And that's not really what we want. We'd want the next, or the latest version of pip. But we also want it to be working alongside Python 3. So we can make a change in user bin. So pip is pointing to Etsy alternatives pip there, which is fine. However, here we'd prefer that pip actually pointed back to user bin pip 3.6 rather than to what it's pointing to now. So we can go ahead and sudo move pip to pip 2. We can create a symbolic link, sudo ln -s user bin pip 3.6 to be both pip 3 and pip. We'll come back to our home directory and take a look at pip -v Now we can see that we've got pip version 903, but it's working alongside Python 3.6, so that's better. But I guess I haven't shown you yet, but as soon as we go to use pip, it's going to recommend that we upgrade to a new version of pip. So I'll show that to you here. So we'll go ahead and run this command. Okay, so we can see that we successfully installed pip 20.1.1, which seems good. However, now that we've done that, we have no pip. And as best I can tell, the reason behind that is somewhere between version 9 and version 20, pip moved from user bin to user local bin. So if we take a look at user local bin, we can see those values are there. We can also see in user bin that the pip symbolic link was removed. Okay, so let's just quickly go back to etc alternatives. So we've got pip2 and pip3. Rather than having those point to really the old executables in user bin, we should probably have them point to the new executables in in user local bin, or at least the pip3 one should do that. So let's go ahead and do that. Sudo remove pip and pip3, and sudo ln-s. We're going to link them to user local bin pip. I could have linked it to pip3 and user local bin, but I went ahead and did that. So we come back to our home directory, pip -v. Still can't access it, and that's because we haven't done anything inside of user local bin. So if I do an ln-s, sudo ln-s etc alternatives, pip and cd, now I should be able to see pip -v, version 20 here, and version 3 here. Okay, so that's really what we want. Before we move on, we want to have a proper version of Python 3, proper version of pip, in order to do the other installations that we're going to do coming up now. Okay, so we can move on to the second section, getting the Chalice app deployed to AWS. So I'm in my home directory. Now I'm going to run sudo pip install virtual env. So this is going to be installing the virtual environment. And these instructions more or less come from the Chalice getting started documentation. Okay, and even though there's a warning there about virtual env not being in the path, I guess what I found before is that it actually is, because I'm still able to execute it. So on this line, what I'm going to be doing is going ahead and creating a virtual environment called Chalice Rosetta Backend. Okay, that's done pretty quickly, and then the next step is to actually source, or short form for source, the dot command, and run this activate script. Which then puts us into this virtual environment. You notice the prompt changed. Now in this virtual environment, let's do a double check and make sure that our Python version and our pip version are correct. They're looking the same as they were before we entered into this virtual environment. So now we're ready to install the Chalice framework with pip. Sorry. Okay, so now that once we have that installed, the documentation says to try and run chalice -- help, and something I hadn't run across before, or at least I didn't remember running across, was this error. And as I ran across it, it seemed like the best way to fix that was just using these two environment variables. And of course those could be put into your profile files, your bash rc bash profile files, to set those automatically, or you can set them whenever you get into this virtual environment. It's up to you. But now we have the Chalice framework responding. Okay, after that we want to get our AWS environment set up, because the Chalice framework uses the AWS command line in order to do some work deploying the backend resources into the API gateway and the Lambda server. So, or the Lambda service rather. So let's go ahead and make sure we can access AWS version command. Notice that it's running Python 2.7, but that's an embedded version of Python with the AWS framework or command line, so we won't worry about that. And just as an aside, the Amazon Linux instance that I started up already had this on here, so I didn't need to install it. Okay, I'm just going to run AWS configure for you. I'm just going to write ABC, DEF, GHI, JKL very quickly into those files, and I want to show you that they create these AWS files for us. But those of course don't have real values, and just before I started the video I had uploaded the proper values for these, but didn't want to show you the credentials. They likely won't be appropriate anyways. By the time this video is done, I'll hopefully remember to delete them and delete the credentials, but just for security's sake I wasn't going to show them to you now. So if I copy this temp config to that AWS config file and then do the same with the credentials, then I will have seeded the AWS command line with the proper information to actually go ahead and deploy the Chalice application. Okay, moving on. So we're going to now stage the Rosetta backend. So I'm going to create a directory called work, and into that I'm going to extract some files that I had also uploaded just before starting the video, and these are the files that, at least these are the files that are described on the CloudDoc website that this video is for. So you notice in there's an app.py file, there's also a Chalice lib directory, and those two things are really the code that make up this backend server, this serverless Python server. Okay, so I won't spend much time talking about that code. It's described fairly well elsewhere. Now let's go ahead and try to use the Chalice framework to deploy. Actually, before I do that, I just want to show you there's a .chalice directory with a config file in it, and I want to highlight these two rows here in the file, 2 lines in the file. These are changes that I needed to make when I was getting this Chalice framework to deploy the application. So I needed to create a Chalice _admin role that had the appropriate permissions to interact with things like Dynamo and SES and the other services that the backend needs to interact with, and then to place those two lines rather into this file. Okay, they're a little bit different than the defaults. Okay, so Chalice deploy, and that's what this is meant to do, is to take the application and deploy it in the back end. But we go ahead and we see that no module named Boto3, so I need to use pip to install that. That of course is the library, the Python library for interacting with Amazon Web Services. Now if I try it again, now I get no module named Jose, and inside of my requirements file I've got the name of the Python module that provides that, so I'll go ahead and install that. Okay, so now I can go ahead and actually deploy this backend, this Python serverless component. And if you haven't seen this before, this HTTPS endpoint gives you the endpoint at the API gateway, and I'm going to use it in a minute. I'm going to use curl and that URI plus a suffix in order to check the version of this application. So if I look at the app.py, if you've looked at the article on the Cloud Doc, some of this will look familiar. Want to highlight this right here, and the color coding may not help, so I'll take that off, but this line right here shows the version, and we see that we can access that by using product-version. That's our suffix. So I want to use curl to interact with that API and then get the product version. So this is a get, HTTP get, and there's no carriage return, but we can see 1.07 is what is returned. So just very quickly, I want to show you how to update your application. I'm going to just make an update 1.08. I'm going to change that, and then I'm going to redeploy. The endpoint stays the same, but now when I curl and go ahead and get that response, you see that it has now gone to 1.08. And if I were to show you the console in AWS, you would see we would see some endpoints in the API gateway. We'd also see some Lambda functions in the back end supporting those API gateway endpoints. So I'm going to go ahead and delete these resources since it's just for the video, and that's it. So I hope you enjoyed it. Certainly I'm available to answer any questions you might have about what I went through, but again, the purpose of this was really just to elaborate upon and extend to show a little bit more in detail what was talking about on the Cloud Doc article, where I described the Python serverless server And this video was to show how to actually deploy it once you've got all those pieces in place. Okay, thanks very much. Hope you enjoyed it. Bye.